Hello, this is Michael Novenson with Information Security Media Group. We're going to be discussing artificial intelligence and machine learning today with Michael Brown. He is the Principal Security Engineer at the Research Practice for Trail of Bits. Good afternoon, Michael. How are you?
I'm great. How are you today?
Doing well. Thank you so much for making the time here. So I know there's really maybe two key intersection points between AI and ML and cybersecurity. What are those intersection points first? And then secondly, why do they matter?
Yeah, it's a great question. So oftentimes when we talk about AI ML security, people really mean one of two different things. They usually mean AI ML systems applied to conventional security problems. We call this AI ML for security. Or they're talking about the security of AI ML systems. How do we achieve security objectives on these new specialized systems that are essentially emerging technology?
Got you. So in terms of applying the artificial intelligence and machine learning to conventional security issues, why is there such a need for that today?
Well, there's a huge need for this because we're finding out that over the last 10 to 20 years, that as Moore's law has given us more computational power, it's starting to trail off, and we're reaching a point of diminishing returns and what type of conventional security approaches we can take, whether it's trying to find bugs or patch bugs or otherwise do analysis on systems for their security properties. So the good news is the computation that's now becoming available with cloud compute, GPUs, they're making a whole new class of AI ML systems available to us. And the capabilities that we have with these systems, they aren't subject to the same limits that our conventional approaches are. So this means we now have the ability to pivot to using AI ML systems either on their own or in conjunction with conventional systems to make new breakthroughs and advances that weren't possible before.
So what do you see as the benefits and drawbacks of using these AI ML-based systems on their own versus using them in conjunction with traditional security practices?
Yeah, so it's funny. The AI ML systems that we build for achieving security objectives, they tend to excel where our conventional techniques start to fail, and they start to fail where the conventional techniques tend to succeed. So we're really finding that complementary approaches that use conventional techniques where they're strong and using AI ML techniques where they're strong, putting them together, you get a best of both worlds approach. And that's typically where we're seeing the best outcomes in these early days.
And in terms of what types of problems can AI ML systems solve that maybe conventional security issues we're struggling with?
Yeah, so this is actually a point that comes up a lot. And the way I've decided to try and help communicate this is when we solve conventional computing problems, we typically do it in what's called a prescriptive way. We write an algorithm, it computes a solution based on input, and then we get the answer, and that's how we go about that problem. But AI ML systems are descriptive solutions to problems. We show a model lots and lots and lots of examples of a problem, what looks right and what looks wrong, and then we expect it to eventually learn through its own modeling algorithm how to solve the problem from examples, so descriptive versus prescriptive solutions. So we're finding that there's a lot of fuzzy, challenging security problems that we typically rely on expert engineers like the people I work with at Trail of Bits. And the problem is this doesn't scale. We can't solve these problems because it's really hard to train and it's really hard to find people who are really, really good at these really challenging security problems. So the breakthroughs that we see AI ML helping us make are targeted specifically on these fuzzy, very intensely human problems. If we can collect enough examples of these problems, we can hopefully create models that can mimic some of the behavior that we get from our human experts today.
So how is this being put into practice? What are some things that are taking place to try to apply AI and ML to conventional cyber issues?
Yeah, this is a really hot topic right now in government research. Specifically, DARPA, the Defense Advanced Research Projects Agency, is currently funding several projects that are trying to apply AI/ML systems apply AI/ML techniques to these conventional security problems. So Trail of Bits is a performer on some of these problems. Most notably, happening today actually, is the AI Cyber Challenge. So this is a competition that DARPA is running at DEF CON, and they've challenged teams like our team at Trail of Bits to automatically find and remediate bugs in open source software, complex real-world open source software. And to do this without the aid of humans, to do this completely automatically, and to do it in a relatively short window, 4 hours of time, and a relatively small budget, only $100 of budget available for accessing third-party LLMs like OpenAI's ChatGPT or Google's Gemini. So we're currently working and we're actually competing as we speak in this competition. And if successful, we'll find that we might be able to kind of tip the scales back in favor of cyber defenders by giving them a tool that helps them achieve software vulnerability detection and remediation at scale.
So I wanted to talk about the flip side of the coin here, that being security for AI and ML systems. So when you think about it, I mean, ChatGPT is certainly the most popular, but there are other LLMs and certainly tons of other AI tools that have become pretty common over the past few years. I mean, how similar or dissimilar are the security challenges around large language models compared to previous advancements we've seen like computers or blockchain?
Yeah, so this is a really great question and something that we're particularly passionate about at Trail of Bits. One of the things that we think is really important to understand and acknowledge right off the bat when dealing with security issues in AI/ML systems is that they are not conventional computing systems. They interact with data and have a relationship with data in an entirely different way, and we have to treat them as such. Otherwise, we miss large sections of the attack surface for systems that are incorporating AI/ML models. So in our traditional, conventional algorithms that are prescriptive in nature, the program operates on data. But for AI/ML systems, the data is how we create our method for solving the problem. So one of the things that our company has been particularly passionate about and really has advanced the field has been in data-borne and deployment-borne vulnerabilities for AI/ML systems. And these vulnerabilities are unique to these systems. There's not really a strong corollary in conventional systems. So I think it's important up front that we acknowledge that these systems are different. We have to treat them differently, and we need to get ahead of vulnerabilities as early as we possibly can in the life cycle for these systems. Otherwise, we're going to repeat the same mistakes that we made with computing in general. And you mentioned before, the blockchain industry and the fintech industry, both of these areas have had a long history of really terrible vulnerabilities that have been in systems for long periods of time. And they've become very costly and very challenging to remediate because they're in deployed systems as opposed to systems that we're building and we can fix easily.
So what's different from a security perspective about LLMs versus previous generations of technology, and what types of investments need to be made in order to address the unique nature of these challenges?
Yeah, the biggest difference is scale. Large language models, one of the things that make them unique is they're using internet scale data sets. They're using cloud compute to be able to both train the models and then run them at inference time. This is really different from the types of AI/ML systems that companies have been building over the last 10 years, 2010 to 2020, typically much smaller and more narrowly focused. So for example, you might have a hotel that is using AI/ML to predict what kind of perks might appeal to certain types of customers. So this is a really narrow goal with the AI/ML system, and it's a really narrow set of data that goes into it. And now we have just a huge amount of data, a huge amount of compute, and the scale of this problem brings issues and vulnerabilities that can only be addressed and are only apparent at scale.
So what needs to happen in order to address security issues in large language models sooner?
It absolutely has to be investment, and we need to start incorporating and creating secure AI/ML system development life cycles. So the same way that we have developed the secure development process for conventional software, I really think it's incumbent upon AI/ML companies and the AI/ML industry writ large to develop these rigorous security policies, starting all the way at the beginning of the pipeline with how they collect data, how they pre-process data, how they manage and train their models. If we don't start now, then we're going to see models go out potentially. And we've actually seen some of this in the form of hallucinations or confabulations or inaccuracies in training data. And these are only going to get worse because we're only going to consume more data, and we're only going to consume more compute to get these systems out the door. So we need to start now.
And finally here, I want to get a sense of what do you see as some of the newer emerging issues or challenges, either around applying AI and ML to conventional security issues or securing AI and ML systems? What's coming down the pike here?
I think that's a great question. It honestly would probably be more about the scale of the issues. I think this is an unprecedented security challenge that we're facing. We've seen this, and we're starting to see this in conventional systems as they've moved to the cloud. But realistically, for large language models and the new types of modeling techniques that are going to be coming down the pipe in the next 5 to 10 years, the scale is going to be unprecedented. It's going to continue to be unprecedented. Right now, ChatGPT and other large language models they're essentially scraping the entirety of the internet for their training data. And there still are some of these pockets of training data that are available that they might be able to bring in and incorporate into their system. And they're starting to do these things now. And these systems, because they require so much data, they're having to rely on untrusted, uncontrolled, and unmitigated or unremediated data sets. And some of these issues are really challenging to address because it's just not practical to scan all of this information or assess its veracity.
It's important stuff. Michael, thank you so much here for the time.
Great. Thank you so much. It was great to be here.
It was great to have you. We've been speaking with Michael Brown at Trail of Bits. For Information Security Media Group, this is Michael Novenson.